Mom, you can't come in when I'm in the middle of my TikTok. You gotta knock next time, Mom. What's up, class? Miss you guys so much. I'm gonna keep saying that because it's so weird being in the school all by myself. So when you guys come back and I yell at you for talking too much, you gotta remind me and say, "Hey, Olsen, this is better than when you were alone, isn't it?" And I'm old. I'll probably forget, and I'll probably just keep yelling at you anyway. But I really do miss all you guys talking. Joke of the day, everybody. By the way, this is online lesson number 3. We're heading off to 9.4 today. But let's start with our joke of the day. And the joke of the day is on me. This is me, back in the 1980s when I was in high school. My mom always wondered what happened to that hairspray of hers. She probably figured it out. But be careful, kids. This is all going to happen to you. Especially if you don't do your math homework tonight. So let's go, everybody. Let's get started. We're going to first talk about yesterday's homework. It was a little tricky, wasn't it, everybody? Well, let me go over some of the solutions for you. So have your homework out, everybody. Here we go. Start with number 15. Number 15 has a square and a rectangle. But the trick is, they're not giving you all the dimensions. If this side's 7, this side has to be 7. If that side's 5, that side has to be 5. But what the heck is this side? Well, this piece and this piece would be the same as this piece. So I got to take this 11, I got to take this 5, add them together, 5 plus 11, that gives me a side of 16. So everybody, now when I have to find the area of this composite figure, I'm first going to find the area of the square, which is side times side. That's my 5 times 5, that's 25. I also have to find the area of this rectangle. A rectangle is length times width. Well, I think I got a width of 7 and a length of 16. I got to do 7 times 16. Ooh, boy. 7 times 16. Well, I know 7 times 10 is 70. 7 times 6 is 42. Add them together, I get 112. Now, I got to take these two areas and add them together. 112 plus the 25 is going to give me 137. Oh boy. And what were those labels? Meters. Meters squared. So the area is 137 meters squared. Perimeter, that should be a little bit easier. Let's see. I got a 5. I got a 5. I got an 11. I got a 7. I got a 16. I got a 7. And then I got another 5. If I add all these guys together, I should get my perimeter. Well, that's 12, 18, 25, 26, 36. 3, 4, 5. I think I have a perimeter of 56 meters, everybody. And woo, the book agrees with me. All right. Moving right along, everybody. Let's take a look at number 16 now. This one's going to be a little bit trickier because I see circles. Well, let's start with that area again. To find the area of the circle, as we just practiced, it was pi times the radius squared. Well, pi is a 3.14. The diameter is a 15. So to find that radius, I got to cut that radius in half, cut that diameter in half, to get the radius, which is a 7.5. Then I grab my trusty calculator and I say, calculator, what's 7.5 times 7.5? I don't have time. And the calculator says, no worries, it's 56.25. Now I just have to multiply that times pi, 3.14. And I get 176.625. Well, that's the area of my circle, which is here and here, but not in here. That looks like a rectangle to me. So to find the area of a rectangle, I got to go length times width, and that would be my 4 times 15, which should be 60. Now, I got to take these two areas and add them together. Woo, calculator. 176.625 plus 60 is equal to 236.625. What was my label again? Feet? Then that is feet squared. That's my area, everybody. Well, now unfortunately I got to find this perimeter, which is going to be the circumference of this circle. Woo, where am I going to find room for this? Let's see if I can squeeze this in down here, everybody. Circumference, they're giving me the diameter, was pi times the diameter. That's a 3.14 times the diameter, which is 15. Trusty calculator says 3.14
times 15 gives me a 47.1. But don't forget about these two little spots. If I got a 4 and a 4, that means I got to add 8 to that. So 47.1 plus 8 tells me 55.1. And we said this was in feet. So my perimeter should be 55.1 feet. Ooh, I got it right. All right, that takes care of 15 and 16. Now let's take a look at number 17, everybody. I hope you recognize we have us a rectangle and a triangle here. So to find the area of a rectangle, one more time, length times width. The length times width would be 6 times 7. And 6 times 7 is 42. Now I got to find the area of this triangle. 1/2 the base times the height. 1/2. Well, what is the base? Oh no. What is the height? Oh no. Well, if this side is 6, this side has to be 6. Here's my 90-degree angle. The height of that triangle must be a 6. Now I've got to figure out this base. The whole distance is 9.5. If this part's 7, this part has to be 7. So 9.5 minus 7 tells me 2.5. That must be my base, a 2.5. Well, before I grab my calculator, I know half of 6 is 3. So now I just got to do the 3 times the 2.5. 2.5 times 3 is equal to 7.5. Once again, I'm going to add these two measurements together, everybody. I think we should have a total area of 49.5. My label again was centimeters. Since it's area, that should be squared. 49.5 centimeters squared. Woohoo! Now, I have to find the perimeter. Perimeter is my distance around. That looks like I got a 6, and a 7, and a 6.5, and a 9.5. When I add those all up, 6 plus 7 plus 6.5 plus 9.5, I got a perimeter of 29 centimeters, everybody. 29 centimeters. Woo-hoo! All right, take a look. Hit pause if you need to, but that's my work with all the answers to 15, 16, and 17. Moving right along, everybody. We got to talk about number 18. Did your friend do it right? No, of course not. What did he do? He said 4 plus 3 plus 4 plus 5 plus 4 plus 5? Plus 5? You can't add the inside measure when you're finding the perimeter. You can't add that 5. I think the perimeter should have been 20 inches on that one. 20. All right, and number 19, everybody, especially for you track stars out there. Why do they have you starting in different places? Well, Olson's answer is, if you're running around the outside of a circle, that's going to be longer than running around the inside of a circle. You deserve a head start. Let's see what the book says. The starting points are staggered, so that each runner can run the same distance and use the same finish line. This is necessary because the circumference is different for each lane. Seems to make sense to me. Hope you all agree. All right, everybody, we're going to move right along. We are now off to